Welcome to Top Tech Voices. I'm Georgia Lewis Anderson, an AI consultant, and your host for this journey into the heart of modern technology, where we're going to be asking what the future might hold. In this series, we're going to get into the big topics, shaping how our world is changing, and question what might be coming next. We're going to be talking directly to the experts who are going to be sharing their insights on the changes unfolding around us as we enter what many are calling the fourth industrial revolution. There's going to be a lot of new ideas and fresh perspectives. So let's get cracking, shall we? When Jaap Haartsen introduced Bluetooth to the world, he did more than create a new wireless standard. He revolutionized the way we connect. With a background in electrical engineering and a passion for communication technologies, Jaap's breakthrough in 1994 has enabled billions of devices to talk to each other seamlessly. So, what might you not know? Bluetooth was initially named after a 10th century Scandinavian king who united Denmark and Norway. And Jaap's own vision for uniting devices has shaped the Internet of Things and continues to impact the tech we use every day. You can expect some fascinating insights from the man whose work literally lives in all of our pockets. It's an absolute privilege to be joined by the inventor of one of the most ubiquitous technologies that has changed the landscape for the Internet of Things. He invented Bluetooth. Welcome, Jaap Haartsen. Hello.
My pleasure. Hello.
Thanks so much for joining me.
Thank you.
So, I've heard that you said invention starts with imagination.
That's correct.
What were you imagining in 1994 when you were thinking about making Bluetooth?
Yeah, well, it started a little bit early, of course, than 1994. Then I started with Bluetooth, but my knowledge about wireless came before that. So I started at the university already looking at wireless communications. And during my PhD work, I was doing something with semiconductor physics where I combined sound waves with electronics. Which sounds quite exotic. But on the side, I was doing some work for a very interesting company, which was called NCR. Maybe you've not heard of that, but that's NCR stands for National Cash Registers. And the company made actually systems for department stores, warehouses, etc. And they had these cash registers. And when they had to remodel the stuff, the cash registers had to be somewhere else. And to have all those cables within the cash registers would be very cumbersome to change it all the time. So they want to have a wireless system. And actually that was a little department in Holland of NCR that was working on what was called WaveLAN. And I was making actually receivers or kind of components for the receiver for WaveLAN. And actually WaveLAN later became Wi-Fi. My initial work on communications was with Wi-Fi. So when I graduated, I got my PhD, I went to the US, I started working on mobile phones. So I was learning all about mobile networks and cordless phones. And when I was about to go back to Europe from the United States, they asked me to work on home base stations. And home base stations was the fact that you used your mobile phone not in the cellular cell as you used to be when you drive around and you have all those base stations. But when you got home, it was connected to your home base station, which was kind of personal base station. And that's where I learned about indoor communications. So combined with the Wi-Fi I already had before the knowledge, I combined that with the indoor communications with cellular phones. I made a specification for that, and that came into the big specification handle. But actually, that never came to something because the base station at home was not controlled by the operators, and they don't like that. Today, you would call that femtocells, very small cells in a very confined area. Anyway, my manager then asked, okay, can you make something that can connect to the phone with these accessories? That was not there already because, we had these, I was working with cordless phones and mobile phones, but not with these short-range connectivity. And that's actually where Bluetooth started. So I was still working with my colleagues in the United States, and there we called it Penny Link. And the idea was that we said, okay, an engineer, he wants to talk with his colleagues on the other side of the world, and he is talking, but he wants to show something, and the picture says more than 1,000 words. So we have to scribble as well. So that's where the penny comes from. It's from the pencil, the stylus. So we had a penny link which connected to the phone, which could then do both data from this stylus stuff and your voice. And that was the product we were working on. When I moved to Sweden, we started to call it MC Link, which is MC stands for multi-communicator. The idea was that you had your phone and you had some kind of PDA, kind of personal digital assistant at that moment, and you should have no cables in between that. So yeah, that should have been then also a wireless link, and that's why we called it MC Link. That was all inside the company I was working in then. That was within Ericsson. At a certain moment, when we came to such a phase that specifications were ready, technology was quite mature, the ideas were very stable. With that, we have to go out because only Ericsson he was making mobile phones. We need to create an ecosystem that can also connect to other devices from other manufacturers. So then we started to look around who is going to join us, that we can come up together and create a community actually to put this system on the market. And it was actually Intel who was the first one who understood the issue. And they said, okay, let's call it a different name. Let's call it Bluetooth. And that was because one of my colleagues, he was talking to an American guy about the history of Sweden and of the Scandinavian world. And we had King Bluetooth there, a Viking king in the 950 or something. And he made actually peace among the people in Sweden. So instead of banging on their head, they were talking with each other. So that's why the communication aspect comes from.
That's such a sweet sentiment that it was the king who made peace with other people, which I can see how it directly relates to Bluetooth, being able to connect with any device from any manufacturer.
Right.
But didn't you originally want to call it something else, Piccolo?
Well, the point was that Bluetooth was like the project name. When we talked about products in our company, we always gave the name. So that when you're talking to colleagues in a cafe or a train and you're talking about somebody, nobody else could understand what you were talking about. And Bluetooth was just a product name for this whole system. So with Intel and other companies later on, Toshiba, IBM, and Nokia, we called it Bluetooth as a project name. But then in 1999, we had to go to the market, and then we said, okay, what are we going to use as a marketing name, a brand name? Then they thought, maybe we should use something like PAN, Personal Area Networking. But when you did Googling, then there was already Google then, you already got hits on PAN. And on Bluetooth, there were no hits. Mm. So they said, okay, let's for the moment call it Bluetooth. We will come up with a brand name later on. Let's launch it now. That was in May 1999. But the name stuck and it never changed anymore.
I'll say it's hard to imagine a world before Wi-Fi, which is what you were saying. And I asked you about imagination, and it sounds like you were imagining a world where things could talk to each other that weren't connected. That's really kind of blue sky thinking, isn't it?
Right.
Especially as it was so long ago, because we had to put wires in the walls that connect to the internet. What are all these things that you've bought me? I feel like we're going to go on a trip down.
So just to a little bit elaborate on that, we had so many different standards as well. We had a lot of different cables with different connectors to it, and nothing fitted with each other. But with Bluetooth, everything was gone because it was only Bluetooth. But let me show you a few gadgets from when we launched the system. So, first of all, I start with the phone. Of course, the phones did not have Bluetooth inside yet, not even Wi-Fi. So, to be able to make this Bluetooth compatible, we had to use an adapter. This adapter was connected to...
I actually remember those, yeah.
It was connected to the system bus underneath the phone. And this one had Bluetooth in there. It is still big. Today it's only a little chip, but at that moment it was a little bit bigger. And that one could then be connected, for example, to a wireless headset. This is a wireless headset from 2000. That was actually made or designed in Holland.
Oh, it's kind of the original Britney mic.
So it connected then to your phone. And if you wanted to connect with a PC, you use the PCMCA card.
Oh, how do you put that in the computer?
Yeah, there was a big hole in there. Today we don't have that anymore.
Yeah.
But we also had these kind of PCMCA cards for GSM later on and for all the wireless. But that was it was in the beginning. So like the year 2000 when we came up with the first product. And yeah, of course, that has evolved quite a lot now.
Well, I was going to ask, when you were putting your headset on and plugging in your extra Bluetooth connectivity and then putting the, essentially some kind of sophisticated floppy drive thing in the computer, did you ever imagine the impact that Bluetooth technology would have? Today we're seeing people with pacemakers relying on it, and it's only kind of getting more and more relied upon, especially for the Internet of Things.
Yeah.
Did you see this coming?
No, not at all. Because actually I'm a research guy. So I'm just interested in technology and solving problems and doing all kinds with technology. So I was in Ericsson Research and this was a nice project. And I also know that if you're working research, well, 99 of the 100 things you're working on never makes it to the market. And of course, I like this idea, but that in 1999, I could not envision that it would be this big. And still, for me, it has gone over decades, of course, until now. I started in 1994, which is 30 years ago. So it was not a big change that in one moment I woke up and then there was Bluetooth everywhere. No, it went very gradual. But the point was that at a certain moment, that was in 2006, I read somewhere an article on the internet that says, okay, there are now 6 billion devices out in the world with Bluetooth inside. And then I thought, okay, now that is a technology that won't go away anymore. Because still, there's always that you have technology, it's being tried in the market, and then it's moved out again. But 6 billion devices out there with having Bluetooth or relying on it, then it's very difficult to imagine that will ever go away.
Yeah.
So then that was for me a moment, this has become really big.
I guess it's kind of like when a songwriter writes a song and then somebody listens to the song and takes a totally different meaning from it, and you kind of give away your child and then people run away. Yeah. What is the most surprising way that Bluetooth has been used that you've seen since you invented it?
Oh, wow. Yeah, well, the point is that there are so many different applications. But I think it was a very long time ago that somebody came up, I'm working in the mine. And he said, I wanted to use Bluetooth in the mines. I thought, oh, well, that was very...
What did they use it for in the mines?
Yeah, for some communication between devices. So, of course.
Wow.
And of course, he could use it in the mines. But you have these tunnels, etc. But later on, as I said, there are so many... people have been imagining so many different ways of applying Bluetooth. That's just unbelievable. And the point was also, I'm not in the applications, I'm more in the technology itself, that I could not predict how robust the system would be. Because we are all making use of the same spectrum. Even Wi-Fi is using that spectrum at a certain band in the spectrum. And if you load all those devices in the same spectrum, where does it at a certain moment collapse? It's like you have a highway with all lanes and you put traffic on it. And the bigger the cars are, the bigger the trucks are. At the moment, you just have a traffic jam. That's the same with radio, actually. And I did a lot of simulations with all kinds of transmitters and receivers and see when the system get down. Because we said, well, it will be sufficient that if we have 10 people here using their Bluetooth independently from each other in the same room, that should be sufficient. But if millions of people are going to use it over the world and they're coming together in a big audience room or something, will it not collapse? Oh, it didn't, because it's a very robust system. And
well, it didn't happen overnight, did it? Was it originally, it only stretched 11 yards? Is that right?
Well, radio is using radio waves, and it depends on your environment how far you come. In this room, it will be very quickly blocked by the door, by the walls. If you are in a meadow, you can get to hundreds of meters. It should cover a house, and we have now also come up later versions where we have extended the range. But the idea was really that it should be just a bubble around you, short range communications. That was the headline.
Mm-hmm. And, is there any ways that it's going to be used in the future that you're particularly excited about?
I'm working myself on things that have to do more in the medical domain. So especially people that are getting older, that are in certain kind of homes where they move more slowly, etc. They have Parkinson, dementia, and of Alzheimer. And I'm working on systems where we help those people with sensors on their body, sensors in their ear, to make life easier. And also, the healthcare is going to the roof with the cost. So we're trying to take measures to counteract that.
Oh, wow.
And that's an interesting area that I'm personally working on at the moment.
Mm-hmm. Yeah, the future of healthcare using Bluetooth must have been something you could never have imagined in 1994. And what is the secret to inventing something? I read that you've had over 200 patents.
Right.
You said just now, like, often you're working on technology that never makes it to the market.
Right.
What is it that gets the special ones over the line?
Inventing is not it's hardly ever the eureka moment. It's more like you're working on a challenge, on a problem, and you want to solve it. And you have to go through all the different ways of solving it, all the different routes, because if you don't go through all of them, you might miss one of them. And the point is, by invention, is that, okay, you come to a very good solution, that's the best out of them, and then you want to, of course, you have to think out of the box, because if it's already there, then it's not a patent worth either, because you can't patent it. But it's a combination of all the things you imagine and the knowledge you have, and all the steps you have taken before about solving it in different ways, that you come up to the best way. Okay, and then you want to patent that, not because it's a great idea. Of course, that you want to patent that as well, but because you want to protect it, that you can make money out of it. That's what actually why patents are made for. And to protect it, that nobody else can get into your area. Because actually what we did with Bluetooth, it's called zero rand. That means that we did not require any licensing for people to pay to use Bluetooth. And that was very uncommon in that time, because in mobile systems and cellular systems, it was all based on patents. That different companies are fighting each other over patents, and they had to pay licensing, cross-licensing to each other. And for Bluetooth, we said no licenses at all, because we want to make it as low cost as possible. But that does not mean that you don't need patents, because you needed patents that others would not create similar systems that would not be compatible with you, and then would have a competing system in the market, and then you're lost. So we had a patent pool where we put in all our patents, and we said, well, you don't have to pay for it as long as you're adhering to the standard and you're developing it the way we have put it in the standard.
Do you think the secret to its success has been that it's free for people to implement?
Yeah, I think so. It was one of the first open community kind of standards that's for everybody to use. So there's one small issue there, that you did not have to pay for the specification. But of course, the specification you can implement in many different ways. And if you implement it, then there might be patents on it with a certain company who was making it, and he would be able to say, okay, you have to pay me for that implementation, but you did not have to pay for the specification.
Because it's quite cool. You could really see it as sort of the first wave of open source electronics.
Right, yeah. And that was back in 1998, that when we created the Bluetooth Special Interest Group.
Alongside, Tim Berners-Lee with the internet, giving it away.
Right.
it's just quite a lovely gesture, isn't it?
Well, the point was also that we said it should not be a burden on the product where you put it in. So it should be low power, so that it would not take much of the battery. But it also should be low cost, so that would not add much cost to the product. And by creating licensing fees on top of it, that would increase the cost. So the idea was we should have a $5 radio in 1999. And I think we were close to that. And nowadays you can get it below $1 or something.
What did Ericsson think when you proposed to give it away for free? Because did they not want to make money from it?
No. Well, of course they want to make money for it, but not from the technology. They want to sell phones. And the whole idea of Bluetooth for Ericsson was to create value to the phone. So buy an Ericsson phone because then it has this value to connect to the other devices. But then, well, Nokia came also in, and we had other, Motorola came in. So, yeah, at a certain point, there was not much of a leading advantage anymore. But of course, the idea was phone technology and phone products, not the selling the technology Bluetooth itself.
Well, I guess imitation is the sincerest form of flattery.
Yeah.
So, yeah. I'm sure there's a lot of engineers who are watching this, listening to this, and feeling very inspired. What skills do you think are the most important to cultivate if someone out there is hoping to be the next inventor of the next Bluetooth technology?
You have to be very open-minded. Because you have to be able to think out of the box. So most of if you do a study, you get your knowledge, and then I don't say that's easy, but most of the people are extrapolating on things they know. And the way of inventing imagination is that you take the step out of the extrapolation of the things that naturally come from what you already know. So to have this open mind of fantasy, that is something you need to have to invent this and to come up with new ideas. But most of all, you have to start with a good basic. Fundamental that you know what you're talking about. You know your I call it ingredients, how you build stuff, and then by making it's like with Lego, you're playing around with things, and the ingredients are the same, but you come up with completely different things that you didn't do before.
You said the word playing,
right?
And I know you've said that before. Do you believe that playing and to play is really important when it comes to being a good inventor?
Yeah, I think so. Because as I said, it's not one thing you're looking at and one solution. You're looking at different solutions, and you're playing with it. It's you're looking at different angles from it. You're using that in different ways, and for me, that is a form of playing. That's what I've always done in my life, and that's also what makes it fun.
Yeah. Well, I guess it's a thin line because on one hand, you just want to play and experiment. But then on the other hand, you need to be looking at the market and what they want. So have you ever found yourselves designing products for what the market want and it's not really working? Or, to what point should engineers be considering that? And then to what point should the next generation of inventors just be sort of like being mad scientists and experimenting?
Yeah. Well, as you said, that's a thin line because if you are too much bounded by the market, then the market is also extrapolating. They are seeing things. Oh, okay, then I want this and this as well. So they don't make the jump. So you have to have. In case of Bluetooth, I was not told by my manager all those restrictions on. It has to be ready by that month or that year, and it must be this market size, etc. I was just left alone, working in my area to work out things. And actually, it's more of a phased approach that you start with this core playing kind of things, and then it becomes it converges to something, and then that's also what we did. Then we went to look at the market. Then we said, okay, now it's something which is people will accept. How are we going to make that and put it on the market? How are we going to create this ecosystem? So if you start with that, we will never come to this core playing stuff.
It sounds like your managers or bosses gave you the time to really play and develop and experiment. So would you say, if you were giving advice to the next generation of business leaders who want to cultivate the next big technology, that they almost need a bit of a hands-off approach when it comes to managing their electronical engineers.
Yeah.
Would you?
Yeah, I would say that, but there's also a good analogy with that. When you look at companies like startup companies, they are very much often they come from spin-offs from big companies. Big companies cannot deal with this creative stuff that you just let people go. So then, a spin-off, that's the only way of then to get things done. That, for example, a big company in the Netherlands, ASML, maybe you heard about they're making all this lithographic stuff for chips. They are part of Philips, but Philips could not deal with it, and it was a spin-off. And well, now it's a multi-billion company. But that's what I see. What's happening? You have this spin-off. They are playing with things. They're trying it on the market. You have these startups. Well, these startups that are successful, it comes on the market, then they are acquired by a big company, and then all innovation goes down again. And then, well, you have some some people within the company who are doing something on the side. They create a spin-off, startups, putting something on the market. So yeah, that's this cycle you see with spin-offs, acquisitions of big companies, and. But I was lucky that within Ericsson, my manager and the area where I working was that he had the approach that he could have some of his people do some free work. And that came to, first with my home base stations, but also with Bluetooth later on.
Well, that's what I was going to say. Do you think that was an anomaly, the fact that you were working in a big company, but you had the time to be free?
Right.
Yeah.
Yeah. Yeah, that's an anomaly because that's not very, very often that you find it. But I would say it's a good advice for big companies.
And maybe for the next generation of engineers who are watching, sometimes I think it's easy to want to work at the big shiny companies that but actually sometimes the smaller, stranger ones are where the more fun happens.
Right, yeah, that's very often too.
Yeah. So you mentioned you've got a personal interest in the future of healthcare, especially when it comes to the older generations. Are there any other industries that you're really excited about integrating Bluetooth technology into?
Well, my own company, we are working with hearing protection devices. So I can show you a little bit about that. So we are looking at custom fit ear tips.
Ooh.
So you put them in your ear and they are... they are Bluetooth connected, so you can make phone calls and you can make listen to music. And especially for people that are working in very loud environment, you have to have protection. But with this one, you still can communicate and you can listen to music, etc. So that's for one thing. But another area where I'm also working on that is has to do with the energy transition we are working on nowadays. That's an issue with the global warming, etc. And we are looking at alternative supplies, energy supplies into your home. And the thing there is that actually you want to control your appliances which you have in the home. We call them smart appliances with the energy which is provided to you. So if you have a lot of solar energy at the moment, you want to connect it to certain appliances. Whereas if another appliance, that, okay, it will take 3 hours for a washing run or something, and maybe clouds are coming, I would rather put that on the grid. So what I'm working on is these kind of systems where the appliances are communicating with a central hub in the house with their energy supplying equipment to control of that, to balance the loads that you have in the house with your appliances and the energy that is provided to you.
Wow. Do you think that Bluetooth can be instrumental in fighting the climate crisis then?
In small ways it can, yes. Because the point is that Bluetooth actually is able to create more intelligence and smartness in your devices by communicating between the devices. And to make things more smart will help you to give at least a certain part to help with the climate crisis.
Wow. And I suppose when you were inventing Bluetooth in 1994, again, you never imagined that 30 years later you'd be helping a device to decide if it should take its power from solar or the other way around.
Right. Yeah.
I've heard that in your personal life, you actually don't use much technology. Is that true?
Well, let me say it this way: I have a big difference between my what I do in private life and what I'm doing in my professional life. So indeed, when I am at home, I don't have all these gadgets around me that I'm completely relying on technology. I want to be self-reliant so that I could exist without technology.
Really?
So yeah, because I see that if your battery runs out and you are at a certain place, yeah, people are. "Oh, what do I do?" I heard from people nowadays that they are on holiday, and they are calling the emergency desk because they can't navigate anymore because the battery ran out of
Wow.
power.
So do you think people rely on technology too much
I
today?
really think so. Yes.
That's quite a shocking statement from someone who invented one of the most powerful technologies of our era. Really? So how do you stay self-reliant without any technology then?
Well, you can. Yeah, how should I say that? Of course, I'm using the technology, but I'm trying not to be completely dependent on it. So when I'm going on vacation, my preference would be to be in the wild, just camping, even without electricity,
Whoa.
and just with cooking your dinner on gas.
And if people are relying on technology too much, how can we combat that and help people be less reliant on it?
Well, that at least you're thinking about alternatives, because well, we are living in a strange world. Suppose that electricity falls out now, all stoplights go down. It will just be chaos. So and that means that we are so much reliant on electricity and this technology that our normal life cannot continue. Even I talked about traffic, but also with water and provisioning, etc. I think it scared me a little bit that how much of that is controlled by technology and how we are dependent on it.
Mm-hmm. And when you're camping and you're in the woods and you're doing your cooking, do you ever have visions for the future of the electronics industry? Like, what would you like to see happen?
Well, of course, as I see where I'm working on that, electronics is all around us. It makes life easier. And what I see is that in the electronics industry nowadays, what we are pushing for are three things. Things have to be faster, things have to be lower power, and things have to be lower cost. So that means that they have to be smaller. And that's always been the drive for electronic engineers to create their systems and their components. And I'm seeing it's still happening that I don't know whether you have heard about the book Singularity of Ray Kurzweil. He says that I think it's in 2030 that machines will be smarter than humans, and they will. I don't say well, they will take over the world. But the point is, I don't believe that they will take over the world. But maybe what I'm scared of that we lose control over what we are doing, and that there might be only a very few people that understand what's going on. Maybe your own environment with artificial intelligence. There's only a very small amount of people that knows about what's going on, and the rest of the people doesn't know, and that big gap between the people that know and who don't know, that's getting bigger.
Do you think that's likely to become reality?
Yeah, I do.
Really?
Yeah, because now already there are a few people who understand certain parts of the technology, and the rest is just depending on it.
The knowledge gap is something that we have
Right?
to
Yeah,
watch
that's
out for.
what. Yeah.
Do you think quantum computing is going to play a role in this?
Oh yes, for sure. When I'm thinking of quantum computing, it's about cybersecurity, because everything we do with our devices and what's also being scary now with all the faking of personalities, etc. We always do authentication to know where you're talking with, encryption to encrypt everything so nobody can eavesdrop of that to keep your privacy and keep your data yourself. And with quantum computing, actually, that is on. I see it as being threatened because can we keep these kind of security levels and authentication levels, etc., even when the quantum computing is there? Or do we have to come up with new technologies that use quantum kind of technologies with crypto, etc., to counteract again? It's always this fight against counteracting and trying to break things. But with quantum computing, it's really about the security. I'm quite worried about and thinking about how to solve that in our electronic devices.
Yeah. So talking about new technologies, I imagine when you're working on Bluetooth, people must have thought it was quite weird. Is there any kind of new technologies at the moment that seem strange that you predict are going to be big?
Well, I don't think they are strange, but one of the things I'm thinking that has a great future is that I was saying about these electronics we are working on. The drive is in getting them faster, lower power, and a higher density. A big issue is that they take a lot of. If you make smaller and smaller devices, you have issues with heat. You have to get rid of the power they dissipate. So. Heat is an issue nowadays, and by using, instead of electrons to go through your circuits, use photons. That's what we call photonics. So instead of doing everything with normal transistors, with your electrons, etc., and your holes, using photons, I think that has a big future, because also the power consumption is much less. It's very fast. We have our fiber stuff to our home, but using photonics to control that. So photonics is still at it's not mature yet, I think, but I think that is one of the areas I see that is coming and may take over the normal silicon transistor circuits.
Sounds exciting. So, you mentioned that the reason Bluetooth was so successful was because it was essentially given away for free. And you said that you are scared of a world where some people know things and some people don't. Bluetooth has become a global technology. How do you think, politics and economics might affect the next generation of global technology in the future?
Let me see. There are a number of issues that we are seeing a lot of protectionism in the world nowadays. And I don't think that's going good for open standards and for working together. So that's for one thing that I think trade policies, etc., to keep things for yourself, that is not a way to innovate and to bring things to the world. Other things that are happening in the world, we are seeing conflicts in different parts of the world, and that means that industries like defense industries are getting more attention now. And finally, with the global warming, that also is in the things that are happening nowadays. We have to come up with new technologies to help fight this global warming issue. So when I'm looking at these different sectors, that I would say that is important to go.
Do you feel passionately that in the era of climate change that legislation should be used to make innovative technology open source?
Legislation is a little bit a hard word for that, but I think we should strive that it will benefit everybody, of course. But it's a global thing, and even the cause of the climate can be certain countries, but in the end, it's globally affecting us. So to help it getting down should also be treated globally.
It's clear that you're really passionate about sustainability. How can the next generation of engineers contribute to a more sustainable and inclusive future through electronics?
Yeah, so when you look at making products and designing products, I think first of all you already have to think about the end of life of a product. What does it mean when a product is not used for anymore? How much waste will it create? If you look at rare materials, but also dangerous materials, like in batteries. So from the start, you already have to think about how you can recycle your product. The other thing is that if you design a product and you design it with certain components, how do you make sure that the overhead to get the product together is as small as possible? Because if you have to get out components out of Asia, materials out of Africa, all things are going to be transported around the world 5 times before it gets into a certain assembly line, maybe in Malaysia, and then it's in big containers moved to the United States. All the transport of those will create a lot of pollution as well. So think about how you create products that can be maybe locally put together, also with local components, so that the transport between the different areas can be minimized.
While Bluetooth is used in billions of devices, it does have a couple of competitors. Would you agree? How do you feel about the advent of Zigbee and Wi-Fi, and do you think it threatens Bluetooth at all?
Well, first of all, I think they don't threaten, but I'll explain also why I think it is. As I told you in the very beginning during my studies, I already had some exposure to Wi-Fi. And actually, when we created the Bluetooth SIG in 1998, people from Wi-Fi became very interested in what we are doing. And the reason was that we're using the same spectrum, the resource where we use the radio for, as they were doing. So they saw us more as a threat of eating a little bit of their spectrum. And why not should we use Wi-Fi as well? Actually, they became part of the Bluetooth SIG. For example, Lucent, which came out of this NCR company where I was talking about. Because Lucent was promoting Wi-Fi, and they thought, well, let's get in the board of the Bluetooth SIG, then at least we can control what's happening if they're also going to use that spectrum. And it was very much agreed upon that Wi-Fi was application was to get rid of the cable of the Ethernet. So the only application of Wi-Fi actually was to access the internet. That was Wi-Fi. And what you want to do then is to get it faster. That's what Wi-Fi has been doing with all their releases. Bluetooth had a lot of different applications. It's audio, it's voice, all sensoring, etc. And actually, it's not only one application we're talking about, and therefore we create these profiles that for each application you have a certain profile where you optimize the system and the specification for that specific use case. But anyway, to be able, we said, okay, we should be peaceful working together in the spectrum which we both use. And one of the things which was first worked on in, I think in 2000 or 1999 when we got the first release, was to use adaptive, what we call adaptive frequency hopping. And that means actually it's some kind of cognitive radio that Bluetooth was looking in the radio spectrum. Where is Wi-Fi? And okay, I'm not going to sit on Wi-Fi because then I'm going to disturb them. So in that way, we already were working together a little bit, that Wi-Fi and Bluetooth were coordinating with each other, not directly, but by this cognitive radio in Bluetooth to avoid each other, so to say. And actually, that has been up until now. We have Wi-Fi in the phone, but also Bluetooth. We have systems there that make sure that they are not going to transmit and receive at the same time. We call that packet traffic arbitration. So that's all done in the chips. Today, the chips have both Bluetooth and Wi-Fi combined. So that's all more in a way peaceful. I've always been approached by people who said, yeah, Wi-Fi will, in the end, it will just overrule you and Bluetooth will go out. And we had Wi-Fi Direct, but in the end, it never came. So Wi-Fi, the drive there was to get high speeds, and well, the concern for lower data rates and lower power consumption was not as big as in Bluetooth. So we kept that always this advantage, and that's why there's still Wi-Fi and Bluetooth in the phone. Wi-Fi for accessing the internet, Bluetooth for the short-range connectivity around us. That's one thing. And then you mentioned another part that was a Zigbee. Zigbee has been around for quite a long time as well. It was mainly a proposition for the home automation, where you did lighting control, etc. And well, the issue with the Zigbee was, or the advantage with Bluetooth was that it went into the phone. And by the growth which we have seen in the market of the phones, which went from millions to billions of phones, that also helped to get Bluetooth in the market. Zigbee did not have that advantage. And what we have seen is that if you want to interact with your phone or with your laptop or whatever with a Zigbee system, you always had to have the hub where you did a translation between Zigbee and Bluetooth or Wi-Fi or whatever other standard you had. And that so far has been a big disadvantage, as I see. In the meantime, Bluetooth went to what we call Bluetooth Low Energy, which was a more variant which was also targeting the applications of Zigbee with longer range, sensors, lower power, mesh networking. And actually, that is existing now. It's part of the Bluetooth standard. So I see it more and more that actually Bluetooth is moving away the Zigbee implementations. That will be more and more difficult for Zigbee to keep up their system in the market, because Bluetooth will also do the home automation, office automation, etc.
Okay, it doesn't sound like you're worried then.
No.
How do you feel about the advent of nanotechnology?
Well, nanotechnology, with nano layers, I have one example, and that's very close my personal life, is that my son, he's also doing physics, and he's working on nano layers up into an atom thick. That means that he was looking at a lattice where electrons are moving, graphene it's called, where we could where the intention is maybe that we can make transistors that are very fast, because the electrons going to the lattice don't see any they don't see the lattice anymore, so they can move very fast, and that makes the possible to make high frequency components. For the rest, nanotechnology itself is already a little bit of the past, I would say. When I 10 years ago, when I was at university, everywhere where I wrote in nano, it was possible to get a grant. But layers we are using now for coating, for example, to cover up our devices and sensitive components. But as I said, for the ones where you go from 3D to 2D, I think you see there big opportunities.
What is the new word that when you write it on applications, you're guaranteed to get a grant?
Artificial intelligence.
Of course, yeah.
No, really, even in I'm working on now, even with the healthcare, by the way, that we are looking at sensors, we're getting data out of there, and we're trying to interpret these kind of sensor data. And artificial intelligence is the new possibility of doing that. I'm not saying that it solves everything, but at least it's coming, and we have different applications nowadays that we are looking for implementing this artificial intelligence. So that is the new code word where you have to put in your grants to get money.
How do you think the relationship between artificial intelligence and electronics is going to evolve?
Well, I see artificial intelligence is a post-processing, so it runs on electronics, and the point is that it depends on how you implement it. So artificial intelligence, depending on what application you're looking at, maybe needs millions of nodes. That may be difficult to get in a small earpiece which I put in my head. If you can then create what we call neural processing devices, that you can actually reduce your amount of nodes and optimize it in such a way that you optimize it for a specific application. That are the new ways of getting artificial intelligence into devices with limited power consumption and limited processing capabilities.
It's exciting, isn't it? Sometimes I wish I was back at uni now in the age of AI, because there's so many different ways you can use it to learn.
Yeah.
Do you think it's an exciting time to be an electronic engineer in the age of AI, and can you see it kind of helping the process?
Yeah, as I said, to study electronics and electrical engineering, it has so many different ways you can look at it. As you said, it's artificial intelligence. It's about signal processing, about software. But you can also go to the other way. You can go into materials. You can look at antennas. You can look at electronic circuitry. So there are, I always see in 3 levels. You have the materials, the circuits, and then you have the systems. And in all those 3 areas, it's so many things you can do. And one thing is for sure that it moves so quickly. So you have to keep learning, teaching yourself, learning with new things, because every 10 years the world has completely changed within electronics.
And finally, what are you most excited about in the future, whether it's electronic based or camping in the woods?
Well, I'm as you said, I'm not relying on electronics in my personal life, but I think it's great to work on electronics, and I still think that we exponentially grow and see new things with electronics also in the near future. We are now getting close to where Moore's law is ending, that every 18 months we have an increase by a factor of 2. But still, there are other ways that still we are so innovative that we get new stuff. And electronics is just, I think it's the best profession you can choose anyway.
Wow. Okay, well, thank you so much for some incredible insights from a true pioneer of our future.
It was my pleasure.